Welcome back to the deep dive. Today we are doing something a little bit different, a little special.
Yeah.
Usually, we take a stack of articles, maybe a book, and we try to distill it all down to get you the key insights. But today we're going to play a game.
It's a simulation. Yeah. And a pretty high stakes one at that.
Exactly. We're going
Yeah.
to be a fly on the wall for a job interview, but not just any interview. We're looking at a senior engineering role assessment for a huge, major financial institution.
And the stakes here are, they're incredibly high. You're looking at this clash of two completely different worlds. You've got the old world of institutional banking, stable, secure, maybe a little bit slow. And it's colliding with the new world of decentralized finance, of smart contracts, and even AI.
So, okay, let's introduce the players in this game.
Yeah.
In one corner, let's say the blue corner, we have the company. And we actually have the real job requirements for a senior back-end developer role at BNY Mellon.
BNY Mellon, the Bank of New York Mellon. Just to set the stage, we are talking about the oldest banking corporation in the United States. They hold something like $40 trillion in assets under custody.
40 trillion.
They are the literal plumbing of the global financial system. So, when they decide to hire someone for a senior role, they are not messing around.
Okay, so that's the company. And in the other corner, the red corner, we have the candidate. We have the actual resume of one Sachin Chitre. He's a British citizen based in London. And just glancing at this document, 20 years of experience.
20 years. This guy has seen a lot. He started his career in India back in 2003, then moved to the U.S., and has been in the U.K. since 2010. He's worked everywhere: retail, insurance, startups.
He actually calls himself a unicorn profile on the resume.
And you know what? Looking at this mix of skills, I'm inclined to agree with him. It's this really rare combination of heavy enterprise Java development mixed with decentralized smart contract development. You just don't see that every day.
So that brings us to our mission for this deep dive. We are going to dissect this candidate's technical architecture choices, piece by piece. We really want to understand how these modern smart contracts are supposed to integrate with, the legacy microservices that run the world.
And we're going to judge, based on the evidence right here in his resume, if Sachin has what it takes to build the next generation of banking software.
And we are going to get technical. We're not just going to say, oh, he knows Java. No.
Right.
We're going to talk about how he uses it. We're going to get into Solidity syntax, architectural patterns, the real nitty-gritty of integration.
Let's do it.
Okay, let's jump in. Section 1. The core competency, the absolute baseline, the BNY Mellon job description, it leads with this. As a senior back-end developer, you will be instrumental in designing, developing, and maintaining the back-end of complex microservices architecture. Can you translate that from corporate speak for us?
Complex microservices architecture is basically code for our system is way too big to run on one computer. In a monolith, the old way of doing things, you have one giant application. In microservices, you have maybe hundreds of tiny little applications all talking to each other. One handles the user login, another one handles the loan calculation, a third one sends the email notification.
And they're all separate.
All separate. So BNY Mellon specifically asks for expertise in Java microservice development to ensure, and this is key, scalability, performance, and robustness.
So the interviewer sits Sachin down first question and says, we need to ensure scalability for a next-generation loans processing application. How do you design for this using Java Spring Boot? Does he have the evidence to answer that?
Oh, he absolutely does. You just have to look at his most recent tenure at Direct Line Group UK from 2019 to 2024. Direct Line is a massive insurance company.
Okay.
And he says right here he led the development of a cloud-native fraud detection scoring engine.
Fraud detection. Okay, that sounds like a very high-pressure environment.
It's the ultimate pressure test for a system. Imagine thousands of people applying for insurance or making claims all at the same time. The system has to score every single one of them in milliseconds to catch the fraudsters.
If it lags, you lose customers.
Exactly. And if it breaks, you lose millions of dollars.
Yeah.
And Sachin built this using Core Java 8 all the way up to 17, and specifically Spring Boot.
Okay, so why Spring Boot? BNY Mellon asks for it by name. What's so special about it?
Spring Boot is, it's pretty much the industry standard for enterprise Java. The main thing is that it forces you to write code in a very structured, opinionated way. It manages your dependencies, your database connections, your configurations.
So in a bank, you don't want clever, artistic code. You want predictable code.
You want boring, predictable code that works every single time. Spring Boot gives you that structure. But look closer at the specific libraries he mentions. He lists Spring Batch and Spring Data. That's telling.
What do those two do?
So Spring Data is about simplifying how your code talks to the database. Instead of, writing these long, complex SQL queries by hand for every little thing, Spring Data handles a lot of that heavy lifting for you. It's an efficiency thing.
And Spring Batch.
Spring Batch is even more critical for a place like a bank. Banking is full of batch processing. Think about it. At the end of every day, you need to reconcile all the accounts. You need to calculate the interest for 1 million different users. You can't just do that in a single web request.
Right, because if you try to write a loop through 1 million records in a normal request, the user's browser would time out, or the server would just run out of memory and crash.
Precisely. And this is where the seniority really shows. A junior developer might just write a simple for loop. For every user, calculate interest. It works fine when you test it with 10 users. It completely falls over with 10 million.
So what does Spring Batch do differently?
It handles something called chunking. So instead of trying to load all million records into memory, it grabs, say, 1,000 records. It processes them, commits them to the database, and then, crucially, it clears that memory. Then it grabs the next 1,000, and so on.
Okay, that makes sense.
But the most important part for a bank is that it handles transaction boundaries.
Unpack that for me, transaction boundaries.
Okay, imagine the computer crashes halfway through the job. It's processed record number 500,000, and then, poof, the power goes out.
Nightmare scenario.
It's total nightmare. If you just wrote a simple script, you have no idea what to do. Did the database save the changes for the first half? Do you have to start the whole thing over? And if you do start over, do the first 500,000 people get their interest paid twice?
Which would be a career-ending bug in a bank.
Precisely. Spring Batch tracks the state of the job. It knows, I successfully finished chunk 500. I crashed. When I restart, I'm going to begin at chunk 501. That's called restartability. The fact that Sachin even lists Spring Batch on his resume tells the interviewer he understands that data integrity is even more important than raw speed.
That's a great point. He also talks about the infrastructure, not just the code. It's about where the code lives. He lists AWS Lambdas, API Gateway, and Kubernetes, or K8s.
And that's where the scalability answer really comes from. He specifically mentions horizontal pod autoscaling, or HPA.
Okay, let's break that down.
In the old days, if your website got slow, you bought a bigger, more powerful server. That's called vertical scaling.
Right.
In the modern cloud world, especially with Kubernetes, you don't do that. You just add more small identical servers. That's horizontal scaling.
And HPA is like the automated traffic controller for that.
Exactly. HPA is a system that just sits there and watches the CPU usage of your fraud engine. If it suddenly spikes, say a big marketing campaign goes live, Kubernetes automatically, without any human intervention, skins up 10 more copies of Sachin's application to handle the load.
And then when the traffic drops off...
It just kills them to save money. It's incredibly efficient.
Oh, wait a minute. I have a question about that. We're talking about Java here, and Java has this reputation for being, well, a bit heavy. It has that JVM warm-up time. So if traffic spikes right now and HPA spins up a new server, doesn't it take like 30 seconds or a minute for that new Java server to actually be ready to take a request?
That is a fantastic point, and it's the classic cold start problem. It's a huge issue. If you just naively slap HPA on a heavy, traditional Java app, you will fail. The traffic will hit that new server before it's ready, and the user just gets a 503 error page.
So how does a senior developer like Sachin get around that? You can't have that at a bank.
No, you can't. He most likely uses a couple of techniques. One is readiness probes in Kubernetes. This is basically a configuration that tells the load balancer, hey, I'm spinning up, but do not send me any traffic until I give you the green light.
So it waits until the app is fully warmed up.
Exactly. He might also use something like over-provisioning or even predictive scaling, where you look at historical data and spin up the extra servers before the spike is expected to hit. The resume says he replaced an expensive external provider with this in-house solution. You don't get to claim success on a project like that unless you have definitively solved the cold start problem.
Okay, one last thing on this section. Security. BNY Mellon, obviously, is dealing with incredibly sensitive financial data. Sachin's resume claims he reduced security vulnerabilities by 60%. It's got a very, very bold number.
It is, and you'd get grilled on it in an interview. But he backs it up with the how. He lists the technologies, OAuth 2, JWT, and IAM.
We see these acronyms everywhere, but in the context of a bank, what do they actually mean?
Okay, so OAuth 2 is the standard protocol for authorization. So what happens when you see a login with Google button? But in a bank's internal system, it's log in with your BNY Mellon corporate ID. It's about delegating trust.
And JWT.
JWT, or JSON Web Tokens, are like little digital passports. When you log in successfully, the system gives you a token. And for the next hour, or whatever the time frame is, you have to carry that token with you to every single microservice you visit.
Why is that better than the old way of doing things?
Well, the old way was often session stickiness. The server itself remembered you. But in Sachin's world of auto-scaling Kubernetes pods, the server you talked to 5 seconds ago might not even exist anymore. It might have been destroyed to save money.
Okay.
So the server can't be responsible for remembering you. You, the user, must carry your credentials with you in the form of this JWT. It's what allows the whole architecture to be stateless, which is key for scalability.
And last one, IAM.
Identity and access management. This is usually at the cloud provider layer, so AWS IAM. This doesn't control what users can do. It controls what the servers themselves are allowed to do.
Okay, so like, can the fraud engine service read from the main customer database?
Exactly. If you don't lock this down properly, a hacker who manages to break into the less secure fraud engine could potentially steal the entire customer database. Sachin implementing IAM properly implies he operates on a least privilege or zero trust model. Every single component only has access to the absolute bare minimum it needs to do its job, and nothing more.
So for Section 1, I think the verdict is pretty clear. He speaks the language of enterprise Java fluently. He knows Spring Boot. He knows how to make it scale. He knows how to make it secure.
He passes the safe pair of hands test. The hiring manager can now relax a little bit. They know he can do the day job. But now, the interview pivots. This is where it gets interesting.
Section 2, the pivot. We go back to that BNY Mellon talent profile, and it's just fascinating. Right in the middle of all this corporate Java talk, there's this one bullet point. Experience with Ethereum, Hyperledger Besu, and EVM-based platforms.
This is it. The nice-to-haves are rapidly becoming the must-haves. Hyperledger Besu, for instance, is an Ethereum client specifically designed for enterprises. It lets you run your own private blockchain, or it can connect to the public Ethereum mainnet.
So the fact that BNY Mellon even lists this means they're not just thinking about it, they're actively experimenting.
Absolutely. They're probably looking at asset tokenization. Maybe they want to represent corporate bonds or real estate loans as tokens on a blockchain to make them easier to trade and settle.
So the interviewer leans forward and says, okay, Sachin, you clearly know your Java, but we have this new directive from above. We need to integrate blockchain. What is your hands-on experience with Solidity coding?
And this is the moment. Sachin slides his resume across the table and points to his side project, ChainCron. This is his unicorn project. He built it as part of something called AI Forge. It effectively makes him a dual-class character in this RPG.
I love that analogy.
He's a level 20 Java paladin, right? Safe, reliable, powerful. But he's also multi-classed into a level 10 Solidity sorcerer. He can sling spells.
Okay, let's look at the tech stack for this sorcery, for ChainCron. He lists Solidity, of course, but he also specifically lists Hardhat. What is that?
Yes. Okay, so if you're just a casual blockchain dabbler, you might use a tool like Remix, which is a simple browser-based coding environment. If you're a bit more old school, you might have used a framework called Truffle, but listing Hardhat shows that he's up to date with modern professional standards.
And why is Hardhat considered the professional choice right now?
In a word, debugging. Solidity is notoriously difficult to debug. Once a smart contract is deployed on the chain, it's immutable. If there's a bug, it's there forever. You can't just patch it. Hardhat gives you a full-fledged local Ethereum network that runs right on your laptop. It gives you proper stacked traces, meaning if your code crashes, it tells you exactly which line caused the problem. It even allows you to use console.log inside your smart contract.
Wait, console.log inside the blockchain?
It sounds so basic to any web developer, but in the crypto world, that was a revolution. Before Hardhat, if a transaction failed, the error message was just reverted. That's it. No reason why. You had to spend hours just guessing. Hardhat lets you actually print out the values of variables during execution.
Okay, that's huge.
But the real senior level feature of Hardhat is something called mainnet forking.
What on earth is that?
Okay, imagine you're building a trading bot. You want to test how it interacts with a real, complex, decentralized exchange like Uniswap. You can't just deploy your untested code to the real mainnet. It would cost real money in transaction fees, and a bug could be disastrous. With a single command, Hardhat can download the entire state of the real Ethereum blockchain as it exists right now and run it as a simulation on your laptop. You can then execute your test transaction against all the real live data from Uniswap, but without spending a dime or risking anything.
Wow.
Listing hard at implies that Sachin tests his code against reality, not just in some sterile, isolated vacuum.
Okay, so he's using the pro tools. Now let's look at what the project actually does. The description says, on-chain workflow creation, execution, and monetization.
And that right there is a very, very difficult engineering problem to solve on a blockchain.
Why is it so hard?
Because smart contracts are fundamentally passive. They're lazy. A smart contract cannot wake up at 9 a.m. on a Tuesday and check the price of a stock. It only ever runs when someone, an external person or system, triggers it by sending it a transaction and paying a gas fee.
So how can you possibly build an automation marketplace where things are supposed to happen automatically?
That's the million-dollar question. If I want to create a contract that automatically buys Bitcoin for me when the price hits $50,000, something external has to constantly check the price and then tell the contract, hey, the price is 50K now, wake up and run.
Right, and that's the Oracle problem I've heard about?
Exactly. That is the Oracle problem. And Sachin's resume specifically answers how he solved it. He lists Chainlink oracles.
Ah, I see that. Implemented on-chain automation engine using smart contracts and Chainlink oracles.
Right, so Chainlink is a decentralized network of nodes. Their job is to fetch off-chain data, like the price of gold from an API, or the weather in London, or the result of a sports game, and then reliably push that data onto the blockchain so that smart contracts can read it. By using Chainlink, Sachin solved the fundamental isolation problem of the blockchain.
But his project sounds like it goes further than just reading data. He mentions scheduling and execution.
Yes, and that's the next piece. He's likely using a service called Chainlink Keepers, which is now called Chainlink Automation. It's a service that allows you to register your contract and tell the Chainlink network, hey, please check this specific condition in my contract every hour. If that condition ever becomes true, then execute this other function for me.
So that's the automation piece.
That is the automation piece. And writing the Solidity code for that is complex. You have to manage the gas costs very, very efficiently. If the check you're asking Chainlink to perform is too expensive, the automation service will quickly drain all of the user's funds.
So when BNY Mellon asks about his experience with EVM-based platforms, Sachin isn't just saying, oh, I bought some Ethereum once on an exchange. He's saying, I have programmed the core logic that allows passive smart contracts to securely interact with the real world on a schedule.
And that is exactly what a bank needs. They aren't going to build a blockchain that just exists in a vacuum. They need their blockchain applications to talk to their existing systems for loan rates, their customer databases, the Federal Reserve's interest rates. He's proven he can do that.
Which brings us perfectly to the most technical part of this whole deep dive, the actual integration. Section 3, the bridge between these two worlds.
This is probably the hardest, most intense part of the interview. The BNY Mellon interviewer leans in. Okay, Sachin, we have a massive existing RESTful API architecture written in Java. We have a complex microservice mesh in. How on earth do we integrate a Solidity smart contract into that? How do you handle the syntax differences? How do you manage the insane latency of a blockchain?
It really is like trying to plug a USB drive into a potato. They're just different substrates entirely.
It's a great image. Okay, let's look at Sachin's hybrid stack for the ChainCron project. He lists Next.js and Node.js Web 2, talking to Solidity Web 3. The absolute key here is what he calls the authentication bridge. He mentions secure role-based access, RBAC, and SSO combining Web3 wallet plus OAuth 2.
That sounds like a complete contradiction. I mean, Web3 is all about anonymity, right? Your wallet is your identity. OAuth 2 is all about corporate identity. How do you possibly merge those two concepts?
That is the challenge. And it's a pattern that a bank like BNY Mellon would desperately need to figure out. Here is how Sachin likely solved it. First, the user connects their crypto wallet to the web application using a library like Wallet Connect or RainbowKit, both of which he lists.
Okay, so now the browser knows my public wallet address.
Correct. But the back-end server doesn't trust the browser. Anyone on the internet can send a request to your server saying, hi, I am Elon Musk's wallet. So the server needs proof. It issues a challenge.
What's that?
It sends a unique random string of text, it's called a nonce, to the user's browser. And the server says, if you are who you say you are, cryptographically sign this specific message with your wallet's private key.
It's like holding up today's newspaper in a proof-of-life photo.
That's a morbid but a very accurate analogy. The user's wallet signs that digital newspaper with their private key. The signature is then sent back to the server. The server then takes the signature and the original message and runs a mathematical function on it, usually called acre cover.
And what does that do?
It mathematically derives the user's public address from the signature itself. It proves who signed the message without ever revealing the private key.
Wow.
And if that recovered address matches the address the user was claiming to be, then and only then does the server issue a traditional JWT. But here's where Sachin shows his seniority again. He mentions using RainbowKit.
Which is just a UI library for connecting wallets, right?
It is, but it's a very good one that handles a lot of tricky edge cases, like the chain switching problem. If the user accidentally signs the message while their wallet is connected to the wrong network, say they're on a test net instead of the main Ethereum network, the signature is still cryptographically valid, but the context is all wrong. A junior dev misses that. Sachin's choice of tools suggests he's thinking about these edge cases where real users make mistakes.
So he effectively swaps the user's crypto identity for a familiar corporate identity token.
Exactly. And from that point on, all the other downstream microservices, the Java ones, they just see a standard logged-in user with a JWT. They don't need to know or care about wallets or blockchains. That is the bridge. It's what allows you to build a crypto-powered application that still feels secure and familiar, like a banking app.
Okay, let's talk about the data flow. The resume mentions input, mobile web triggers via deep links, and output, on-chain execution. But crucially, in the middle it says, low latency real-time updates using Firebase plus GCP Edge.
And this is his answer to the interviewer's latency question. Blockchains are slow. Ethereum has a block time of about 12 seconds. Bitcoin is 10 minutes. If a user clicks a button to transfer money, they do not want to stare at a spinning loading wheel for 12 seconds or longer.
So how does something like Firebase help with that?
It's all about optimistic UI updates. When the user clicks the Confirm Transfer button, Sachin's front-end code he's using React with, Next.js immediately tells a real-time database like Firebase this action has been submitted. Firebase can then instantly push that update to the user's screen, so the UI changes from confirm to processing or submitted in milliseconds.
Okay, I see.
Meanwhile, in the background, his Node.js service is taking its time, constructing the actual transaction and sending it off to the slow blockchain.
Wait, hold on a second. Optimistic UI sounds great for a social media app or a startup, but we're talking about BNY Mellon. They handle trillions of dollars. If you are essentially faking the UI state, if you're telling the user success before the blockchain has actually confirmed it, isn't that incredibly dangerous? What happens if the transaction fails 10 seconds later for some reason?
That is the billion-dollar question. And you're right, it is dangerous if you do it naively.
So why would he get hired for doing something so risky?
Because he isn't just faking it. This is where another buzzword from his resume becomes critical. He lists the saga pattern. He's not just painting a green check mark on the screen and hoping for the best. He's likely creating a pending state in a traditional fast database that also locks those funds.
Ah, so he's putting the money into a kind of digital escrow while he waits.
Exactly, a temporary digital escrow. If the blockchain eventually comes back and rejects the transaction, the saga pattern is designed to trigger a compensating transaction, a follow-up action that automatically unlocks those funds and reverts the state. He's building a safety net underneath the user experience magic trick.
The resume also mentions saga, choreography, orchestration. These are big, heavy architectural words. How do they apply here?
Right, so in a complex microservices environment, you have two main ways to manage a process that involves multiple steps. Orchestration is like a conductor in an orchestra. You have one central service that acts as the brain, telling everyone else what to do. Step 1, call the fraud service. Step 2, call the blockchain. Step 3, send the email.
And choreography.
Choreography is more like a troupe of dancers. There's no central conductor. Each dancer just knows that when the person next to them does a specific move, it's their cue to do their own move. They react to events published by other services.
So which one is better for integrating with a blockchain?
Almost always orchestration. Because the blockchain is an external, asynchronous, and sometimes unreliable system, you need a central manager service, probably written in Java or Node, that acts as that conductor. It says, okay, I've sent the transaction to the Ethereum network. I'm now going to wait. I am polling for a result. Okay, it failed. I need to retry it. Okay, it finally succeeded after 3 minutes. Now I will update our internal database and tell the email service to go. You can't just hope the blockchain will tell you what happened. You have to actively manage it.
That sounds exactly like the kind of robustness a bank would need. Oops, the blockchain ate the transaction is not an acceptable excuse during a loan audit.
Not at all.
One more detail in this section. Vercel and CI/CD. He says he uses GitHub Actions to automate contract deployment to testnets.
This is huge. This is basically DevOps for blockchain. A lot of crypto development, historically, has been a bit like the Wild West. A single developer just deploys a multi-million-dollar contract manually from their own laptop.
Which is terrifying.
It's terrifying from an enterprise perspective. You can't do that in a bank. You need an audit trail. You need controls. So what Sachin has done is set up a proper CI/CD pipeline. When he pushes new Solidity code to GitHub, an automated server takes over. It runs all the tests using Hardhat, it runs static code analysis using a tool like SonarQube, and only if everything passes, it deploys the contract. This integrates Solidity development into a standard, boring enterprise software lifecycle. It treats the smart contract just like any other piece of software.
All right, I'm convinced. He can build the bridge. So now we move to the final technical section, section 4, the coding challenge. But it's not just about coding anymore, now it's about AI.
Yes. The interviewer poses a new problem. Look, we want to democratize this technology. We want our non-technical bankers and loan officers to be able to create these smart contract workflows themselves. How do you reduce the complexity?
Because, let's be honest, a 50-year-old banker at BNY Mellon is not going to go home and learn Solidity. They just want to be able to say, create a standard loan agreement for client X that pays out on these dates.
And Sachin, again, points to his resume, to his AI Forge experience. Specifically, the AI-based builder and compose features. He lists his stack, LangChain and OpenAI APIs. And he makes a huge claim. He says he integrated AI-based builder, enabling non-technical users to generate executable workflows via natural language prompts.
This is the holy grail of modern interface design, prompt engineering as code. But how does that actually work under the hood? I mean, you can't just let a user type create a workflow that pays me $1 million every Friday and have the AI write and deploy that Solidity code, right?
No, that would be incredibly risky. LLMs, large language models, are known to hallucinate. The AI might invent a function that doesn't actually exist, or worse, write a function with a subtle bug that allows someone to drain the entire wallet.
So how do you do it safely? What's the senior level approach?
You use the AI as a smart translator, not as a creative coder. What Sachin most likely did, and this is the really smart way to architect this, is use the AI to generate a structured configuration file, probably in a format like JSON.
Walk me through that flow.
Okay. The non-technical user types in their prompt, pay 5 ETH to Bob's address every Friday at noon. Sachin's system would then use a framework like LangChain. LangChain is designed to chain together multiple steps for the LM to follow.
Okay.
Step 1. The LLM parses the sentence. It uses its natural language understanding to identify the key entities. Pay is the action, 5 ETH is the amount, Bob's address is the recipient, and every Friday at noon is the schedule.
Got it.
Step 2. The LLM's next instruction is to convert this extracted intent into a very specific structured JSON format. So it outputs something like action, transfer, amount, 5, asset, ETH, recipient, 0x, schedule, 012, 5, IVE.
It's just so it's not writing code, it's just filling out a form.
Exactly. And step 3, Sachin's backend code takes that safe, predictable JSON and uses it as a set of parameters to call a pre-written, heavily audited, and already deployed smart contract function on the blockchain. The AI isn't writing any new, potentially buggy code. It's just configuring pre-existing safe building blocks.
That's the only way you could ever get that past a security review at a bank.
It's deterministic execution from a probabilistic input. And the fact that Sachin also lists static analysis, the SonarQube SemGrep, in his general skills section really reinforces this safety-first mindset.
Tell me more about SemGrep. I haven't heard of that one as much.
SemGrep is a really powerful static analysis tool that lets you write custom rules to scan code for specific patterns. In this context, Sachin is likely running a scan on the output of the AI or on the generated configuration before it gets sent to the blockchain. He's putting a safety filter on the AI's mouth. If the AI, for whatever reason, generates a configuration that tries to make a transfer to a known blacklisted address, a custom SemGrep rule or similar logic layer would flag it and stop the process dead.
And the resume claims this feature reduced on-chain task setup time by 80%.
And that is the metric that gets you hired. Banks love efficiency. If you can enable a loan officer to set up a complex multi-stage smart contract clause just by typing a sentence, instead of them having to file a ticket and wait 3 weeks for a developer to code it by hand, that is a massive, massive return on investment.
It's really incredible how he's layering all these different technologies. You've got Java for the robust heavy lifting. You have Solidity for the trust and settlement layer. And then you have AI for the human interface layer.
It's a full stack sandwich of the last decade of technological innovation, all in one project.
But, and there's always a but, technical skills aren't everything, especially when you're hiring for a senior role.
No, not at all. Which brings us to section 5, the soft skills, the senior in senior developer.
And the BNY Mellon job description is very, very specific about this. It says things like collaborate closely with product owner, provide input and decisioning, manage and reduce blockers, foster a culture of collaboration.
They don't want a lone wolf who just sits in a corner and codes. They want a pack leader.
So the interviewer's final question is, Sachin, your technical skills are clearly very strong. But tell me, how do you handle blockers? How do you deal with a product owner who keeps changing their mind? How do you mentor junior developers?
And Sachin has a fantastic answer for this, going back to his time at Halford's Retail. This was back in 2018. The resume says he led the platform migration from IBM WebSphere Commerce to a JBoss-based microservices architecture.
Platform migrations are notoriously painful.
They are the hardest projects in software engineering, period. You are literally changing the engines on an airplane while it's in mid-flight with passengers on board.
And IBM WebSphere, that's old school.
That's very old school, monolithic Java middleware. The business logic is often buried in thousands of lines of XML configuration files that nobody has looked at or understood in 10 years. Moving that to a modern JBoss and microservices architecture is less like engineering and more like archaeology.
Archaeology.
Yes. You have to carefully dig up these old pieces of code and figure out why they do what they do. Why is there a line in this file from 2007 that subtracts 1 penny from every transaction? And of course, the person who wrote it left the company 5 years ago. This requires immense communication skills. You have to convince business stakeholders that the potential downtime is worth it. You have to coordinate multiple teams so that no data is lost in the transfer.
The fact that he led a project like that proves he can handle the pressure of BNY Mellon's legacy environment.
Exactly. He understands that legacy code isn't just bad code, it's business value that has solidified over time. You have to treat it with respect, even as you are carefully dismantling it.
And he also explicitly mentions mentored junior developers and conducted peer code reviews.
And look at the specific tools he lists for collaboration. This is key. Pair programming and TDDD Cucumber.
BDD, that's behavior-driven development.
Yes. And Cucumber is a tool that allows you to write your software tests in plain English. For example, a test file might literally read, given a user has a balance of 0 when they try to withdraw $100, then the system should show an insufficient funds error.
Now, why is that considered a soft skill? That sounds very technical.
Because it bridges the communication gap between the technical developers and the non-technical product owners or business analysts. The product owner can actually read the Cucumber test and sign off on it, saying, yes, that is exactly the behavior I want. It becomes a living, executable contract between the business and IT. By listing BDD, Sachin is signaling, I know how to speak the language of the business. He helps prevent that classic argument of, I built what you asked for, but it's not what you wanted.
He also mentions the standard stuff. Agile, Scrum, Kanban.
Standard, yes, but necessary. He's showing he knows how to fit into the existing corporate machine. He's not going to come in and demand they switch to some obscure anarchic workflow. He knows how to show up for the morning stand-up meeting, report his blockers, and move his ticket across the Jira board.
So we've done it. We've dissected the candidate. We've grilled him on Java scalability, Solidity syntax, AI integration, and team leadership.
Now for the moment of truth.
Does Sachin Chitre get the job?
Let's just look at the raw fit. BNY Mellon wants a world-class Java expert. Sachin has 20 years of enterprise Java. That's a check.
Right.
They want deep experience with microservices and Spring Boot. He built an entire fraud detection engine with it from scratch. Check. And then they explicitly ask for Ethereum EVM and Hyperledger Besu.
And that really is the kicker, isn't it?
It's the kicker. Most senior Java developers out there don't know what a smart contract is. And most hardcore crypto developers think Java is a dinosaur from the Jurassic period. Finding someone who is truly deeply fluent in both of those worlds, that is exceptionally rare.
He is the bridge.
He is the bridge. His ChainCron side project fills that specific gap in his resume perfectly. It proves he hasn't just read a book about blockchain. He's actually built a functioning marketplace with it. He's dealt with the real-world pain of oracles, the pain of wallet integration, the pain of unpredictable gas fees.
So I think, barring a terrible personality clash in the final interview, I'd say he's hired.
It's highly likely. He fundamentally de-risks the entire project for BNY Mellon. He allows them to experiment with Web3 technologies without having to throw away their decades of investment in their stable, secure Java foundations. He can build the ChainCron equivalent for BNY Mellon, but he can build it with the rigorous high-security standards he learned at Direct Line.
You know, this whole exercise brings us to a bigger realization. The actual definition of a senior backend developer has quietly shifted right underneath our feet.
It really has. 5 years ago, maybe 10 years ago, knowing Java and SQL inside and out was enough to have a great career. But now, you're expected to be a polyglot, a systems integrator. You need to understand Web 2, the world of REST APIs and Spring Boot for stability and scale. You need to understand Web 3, the world of Solidity and Chainlink for the new tokenized asset classes. And increasingly, you need to understand AI LangChain, LLMs, for building the next generation of interfaces and for logic synthesis.
It's honestly a bit overwhelming to think about keeping up with all of that.
It is, but it's also incredibly exciting. It means the old silos are breaking down. The backend developer is becoming a true systems architect who has to stitch together global liquidity from the blockchain with enterprise logic from Java and human intent from AI.
And that leads me to my final thought on this, a bit of a provocation for you and for everyone listening.
Let's hear it.
We just looked at Sachin's resume. He is building systems where AI agents can schedule smart contracts to move money automatically, 24/7, with the data being verified by decentralized oracles. If a bank like BNY Mellon hires him and he successfully builds this kind of system for them, are we about to witness the end of banking hours forever?
I think we might be. Smart contracts don't take weekends off. The blockchain doesn't sleep for public holidays. If the back-end infrastructure of finance becomes truly autonomous and decentralized, then the very concept of waiting for the bank to open on Monday morning becomes as obsolete as the fax machine. We're moving toward a state of continuous finance.
Continuous finance. I like that.
Yeah.
Well, that's a wrap on our simulation. Whether you are a hiring manager looking for talent or a candidate preparing for your next role, I hope this deep dive gave you a glimpse into the future of technical interviews. Thanks for listening.
Thank you.